Hello everyone, it's your favorite engineer, and today I will show you in a couple of steps how to automate and simplify your work with pickups, with networking using AI, so large language models. Now let's start from the most used tool, which is Wireshark. Wireshark, it includes the tool to convert the pickup files into the text files. This is named TSHARK. And we'll be using TSHARK exactly for this purpose, to extract the data from pickup and to feed the LLM with this information. So what I will be using Ollama framework and the most recent model from OpenAI, which is GPT-OSS. I have a GPU that has 16 gigabytes of RAM, so I can launch this type of model, which is 14 gigs long. And first, of course, you need to download the Wireshark and install it. And once it's downloaded, you can run it. You can, if you have already pickups that you want to analyze, that's okay. But in my case, I will use it to record some data from my Ethernet interface. As you can see, it is capturing something. Let me browse through the net. So I will launch another web page like this, maybe. Let me go to the Google. Right, so there should be some communication going on, and you can see it is here. Okay, maybe I will also launch a Steam client. Okay, now we have some captures, and we can let the LLM analyze this. So let's stop it. Let's save it to the pickup. Let me do it at the moment. So it will be called sample. Okay, now we have this sample. I will try to open it just for you to see. So it is here, and I can now close the Wireshark. It is not needed anymore. Okay. Of course, you need to download this Ollama and install it, and I have already done it. So let me show you. I have a couple of models, but in particular we'll be using this one. So it's 13 gig long. And first let's go to use TSHARK to convert the pickup file, which is right here, into the text data. So there are a couple of methods. I will be using TSHARK from the command line in the Windows. So this is why I have this path here. But in particular, there are a couple of methods that you can apply to this data to filter out necessary communication that you want to analyze. For example, let me display only the DNS requests. So here you put the name of the file that you have stored or you want to analyze. And let me do it like this. Let's display it. What do we have here? Now I'm filtering only for the DNSs, so we can see only DNSs are displayed. Now, for example, I want to display only, I don't know, maybe, as you can see, there's a communication between two IPs, but I want to display something else. For example, I want to filter for this IP address, or maybe for this one. You can also use different filters like this. I will filter only destination IP, so there will be communication that is directed to my PC. As you can see, only these are visible now. There are a couple of other methods. What I will be using, I will be limiting the header size of the IP packets, not to get so much data into the LLM. So this is something that I will do. I will limit the size to 100, and first 100 bytes of each packet will be cut, and then there will be output into the JSON format, and all of those will be stored into this tshark.pcapng text file. And this is something that I will do right now. So let me do it. And now it's done. I can show you what is there. So it will be in the JSON format, as you can see. And you can see the JSON, right? So these are all the first 100 bytes converted into the JSON text file. And now the LLM steps in. So what we will do now, we'll fit the LLM, the AI, with this data. And how to do it? First, of course, you need to use Ollama framework. You have to install it, and then you have to download this model. So you will have to do Ollama pool and the name of the model, and then you start with some prompt. In my case, I instructed the LLM to behave as a network engineer assistant. Let me maybe modify this input and let me ask him to tell me what are the applications that my PC is using and what are the applications that user is utilizing. So we feed the data, we feed the model with this prompt. We include the file, the output from the TSHARK, and then we redirect the output to the text file, so it can be seen later in the notepad. So let's start with this. Now it will start to work. First, of course, I will check what is my GPU usage. So it's now 5 watts of power. Now I will paste it into the yeah, this is the TSHARK that we have just displayed, and now I will be copying this to let the AI analyze. Okay, and now enter, and it should start to work. Okay, right now it will launch the LLM, so you can see there's something going on, but we do not see the output because all the output is redirected to this actually to the text file. So it is now loading this 13 gig. Now it is loaded. As you can see, the power draw increased to almost more than 100 watts. And now it is thinking and trying to analyze this data. We'll see just in a minute what would be the output. We need to be patient because it is now, it is now analyzing all the data. If I click this, so we can see it is already generating some output, but I think it is not yet finished. Yes. So it finished. As you can see, we can display it using CLI or using Notepad. Let's try with the CLI. So it parsed all the data from the TSHARK. We can see that it is describing that HTTP, DNS, LLDP, but we have the final conclusion at the end. This is the list of the protocols that my PC is using. So I was web browsing, I was doing the DNS lookups, file downloads, so maybe there was a file downloaded that I'm not aware of. The conclusion: user is mainly engaging in web-based activities, blah blah blah. And I think the better would be to see it in this notepad because it's now more readable. Okay, so as can you see, using Wireshark with LLM is quite simple. You can automate the processing of the pickups, reasoning of what is happening in the network, in your network, and basically the network engineer will not longer be needed, right? Okay, that's all for today. I hope you enjoyed this video. Thank you very much. Leave a like and subscribe this channel. Thanks and bye-bye.